standard form. Here's our point and it's perpendicular to this. Well, if it's perpendicular, we need to find our slope. So let's subtract 2x. So we have 3y equals 10 minus 2x. Divide by 3. So y equals 10 thirds minus 2 thirds x. Well, here's our slope, but it's perpendicular, so that would be 3 over 2. So here's our slope and here's our point. So let's write it in point slope form. Y equals y1 plus our slope x minus x1. So our y1 value is 5 plus 3 over 2. X, if it's minus 3, it would be plus 3. If we distribute 3 over 2x plus 9 over 2. Let's get rid of these fractions, so let's multiply everything by 2. So now we have 2y equals 10 plus 3x plus 9. And then for standard form, x's and y's on the same side. So we have negative 3x plus 2y equals 19. Our next one here, we have slope-intercept form. Well, let's find the slope. So 5 minus negative 3, negative 2 minus 2, 8 over negative 4 is negative 2. And we can choose any point in slope and fill in the blanks for point slope form again. Y equals negative 3 minus our slope, x minus 2. Distribute negative 3 minus 2x plus 4. So y equals negative 3 plus 4 is 1 minus 2x. All right, and now we start looking down here at a few graphing ones. Well, let's see. If we were to solve for y, we'd have 4y equals 12 plus 3x. Divide by 4. I'm not sure why this is still that inequality. So y is greater than 3 plus 3/4 x. Graph that, 1, 2, 3. Dashed line, so we rise 3, go over 4. And let's test our point 0, 0. Negative 3 times 0, 4 times 0, is that greater than 12? Well, is 0 greater than 12? No. So 0, 0 is no, false. So we'd shade over here. Then we have to graph this one. So let's make our table here for this top one. X is less than negative 2, so we always put in our boundary, negative 3, negative 4. Our bottom table, negative 2, but it's greater, so negative 1, 0. Maybe add a few more since it's a quadratic here. So let's plug that in. When we plug in negative 2, negative 1/2 times negative 2 is 1, plus 1 is 2. Negative 1/2 times negative 3 is 1.5, plus 1 is 2.5. Let's see, a negative 1/2 times negative 4 is 2, plus 1 is 3. So negative 2, 2. I'm going to make that an open circle because it's our boundary point. Negative 3 and 2.5. Negative 4 and 3. Connect those, and that makes sense. Our slope is 1/2. If we kept this going, it would cross at 1, so that works. And this one, let's see, it's a quadratic, so when we plug in negative 2, the opposite of negative 2 squared would be negative 4. The opposite of negative 1 squared would be negative 1. 0 is easy. And then we have the opposite of 1 squared, so that's negative 1. The opposite of 2 squared is negative 4. So negative 2, negative 4, 1, 2, 3, 4. We'll make a closed circle. Negative 1, negative 1. 0, 0. And there's our parabola. So it starts here, but it keeps going on that side when it's greater. So on the back side here, let's take a look at some of these. The 0.32 on the graph is translated. Well, what happened? This is to the right 1, and this is half some value, and it's the entire thing. So that's half our y value. So to the right one would be 4. Half our y value would be 1. What are the transformations? Minus 1. Well, that's to the right one. And this 2, well, that's our entire thing, so our y value times 2. So it's going to get higher faster. Is it even, odd, or neither? So let's see here. And describe the end behavior. So we're going to graph these. Why the calculator's coming up. Oh, here it comes. We'll see if you can get this one here. Come on. So if we were to graph this, 4x to the 4th, then what did we have? Plus 2x squared minus 5. Okay, so it looks like that. If you remember even symmetry, that's the y-axis. Odd was if you can rotate it 180 and it's the same. So this looks pretty even here. I would say we can always double check it. If it's even, f of x equals f of negative x. So there's our f of x. If we plugged in negative x, that would work because a negative squared is a positive. Excuse me, that didn't make any sense. A negative to an even power, that's just going to be, it's the same as if it was positive. So this is still x to the 4th plus 2x squared minus 5. So it is even. An end behavior. Remember, that was filling in these blanks. Here's our end behavior template. What happens at the end? Well, they're both going positive, so it would be going to infinity. So let's check this next one here. Let's see, we got negative 5x to the 5th. Whoops. X to the power of 5. Minus 3x plus 7. Well, this looks like neither. If we rotated it at 180, it wouldn't be the same. Yeah, so this one would be neither. I'm going to zoom out once and just see what this looks like. Menu, zoom out. Yeah, because it looks like it just, yep, if you rotated it, it wouldn't be the same. So we have neither. And then our template, as x goes to infinity, what does y go to? As x goes to negative infinity, gets smaller, what does y go to? Well, if it was when it was positive, it was going down. When x was negative, it was going up. All right, these next two, inverse, those are getting pretty easy. X equals 4y plus 1. Solve for y. We have x plus 1 over 4. Then there's our inverse. Find f of g of negative 1. So our outside function is 4x plus 1. We'll replace that with the g. So let's see, we have 8x squared plus 8 plus 1. So that's 8x squared plus 9. And then we replace that with negative 1. So 8 plus 9, we end up with 17. And some of you might do it the other way too, where you plug it into g first. So 2 times negative 1 squared plus 2. Well, that's 4. And then you plug that into your f. So then there's going to be the review of some exponents here. So we distribute. So this becomes 3 to the 3rd n to the 6th. So we have 27 n to the 6th. So this would be y to the negative 8 times y to the 8. And then we add those. So anything to the 0 power we know is 1. 4 to the 3 over 2 power times y to the 12 over 2. Well, this is y to the 6th, but we can simplify this. Remember, the bottom is the root, so what's the square root of 4 cubed? Well, that's 2 cubed, so that's 8. And then we distribute again, so we have 2x to the negative 8, 2 to the negative 8, x to the negative 8, but we want positive powers, so 1 over 2 to the 8th, x to the 8th. And let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64, 128. So we have 1 over 256 x to the 8. I think I did that right. Let's double check. 2 to the power of 8. Excellent. So we distribute 36 to the 1/2, x to the 6/2. Well, 1/2 is square root, so this is 6x to the 3rd. We distribute here 2n times 1/2, so that's b to the n, b to the negative n when we distribute. Well, we want positive, so that's b to the n times b to the n. That negative exponent, we flip it to the numerator, so that's b to the 2n. Well, let's see here. I'm going to put that to the first power. So 2 over 4 reduces down to 1/2. We subtract, so that would be n to the 1/2. Well, let's see. What do we have inside? Well, that's 81 m to the 1/2, n to the 1/4 to the 4th power. So we have 81 to the 4th. Half of 4 is 2. N times 1/4 is 1. And I wouldn't expect you to do that without a calculator there. So these last couple solving ones, when the base is the same, it's really easy. Those must equal each other. X plus 1 equals negative 2x plus 10. So let's see, we got 3x equals 9, so x would be 3. How do we make our bases the same? Well, they're both powers of 2. So 4 is 2 squared to the x plus 8. So this is 2 to the 2x plus 8, 2 to the 3x minus 9. Set our exponents equal. 3x minus 9 equals 2x plus 8. So that would be x is 17. And this last one, well, it's got to be a base of 3. So that's 3 squared. But it's in the denominator. So to make it in the numerator, that would be 3 to the negative 2. 2x minus 5. So we have 3 to the 4x minus 7, 3 to the negative 4x plus 10. So we have 4x minus 7 equals negative 4x plus 10. So we have 8x equals 17, so x is 17/8.